Good evening, everyone present here. I'll be starting the problem solving sessions shortly. I'll just take a minute for others to join. So please hold on till that.
Comment ça que là, c'est déjà student?
Okay. Good evening, everyone. So welcome back to third week's problem solving session or the interactive session, and today's session will be on glass. So this course is basically taken by Professor Shumana Gupta of IIT Kharagpur, and I am Purvita Shamanto, a PMRF who will be engaged with solving some of the problems. So I'll just take you through our like as I like go through each and every week. So this week also we will be having our interactive session. This happens every week from 6 to 7 p.m. Those who are already joining me are quite aware of how we conduct this particular class. And so you can answer the questions that I'll be asking today. Also, we have a set of questions. So I'll be asking, you'll be answering, and I'll be explaining. And apart from that, if you have any other questions, you can always post it. And apart from that, I think you all are aware of the discussion forum. So there also you can post your questions, and your questions will be clarified. Okay. And so, how is it going to help us? Of course, we have this. Every week we get this particular set of questions, graded assignments are there, and you need to solve them. So basically this particular session is designed in such a way so that you are able to solve the questions that you get. I won't be discussing it directly, but if you attend this class, I'm pretty sure that you'll be able to answer all the questions that are given. Okay. So let's see what has already happened in week 3. If you have gone through the course, so we have seen the lecture 11, 12, 13. These were basically about glass, and lecture 14 was also about glass, but yes, glass wall and glass insulation. And lecture 15 was about ceramic tiles and vitrified tiles. So what we will do today? So in our today's lecture, so basically once again I have mostly theoretical questions from this part, because last week I was solving more of both, the theoretical and this pictorial questions as well. But this week we have more of the theoretical questions only. How we are solving, and we'll see that, and one or two maybe pictorial questions. Okay, and once again no numerical questions this week as well. So that brings to our first question, which is quite an easy one, I hope. So it says that glass is dash and hence it's brittle. So yes, I have started getting answers. It's amorphous. That's absolutely correct. We'll just quickly see into like what this amorphous thing is all about. And this is, I understand, this is a very basic question. We'll slowly move to the the tougher ones maybe. So basically, this amorphous structure of the glass makes it brittle. That is understandable from the course also. But we need, if you look into this particular structure, amorphous structure, there's this crystalline structure, there's this amorphous structure. So crystalline structures are very, like this, somewhat like this. It's very regular kind of a structure. Whereas if you look into the amorphous structure, you'll find that way it is placed is, it's very, you can say it's very irregular in a sense. And since glass doesn't contain the planes of atoms that can, slip past each other, and as a matter of fact, what happens, the stress is not released. Okay, so what happens when excessive stress gets, accumulated, then cracks are formed, and then basically that is how the glass basically separates. Okay, or it cracks or breaks. Okay, so that this entire structure, amorphous structure, gives the entire brittleness of the glass. So how is this, amorphous, how is glass is converted into an amorphous solid? So what happens is that a glass which contains silica. Okay, so we in our in our module we have seen the composition, the ingredients of glass. So it contains silica and it can be easily cooled from its, liquid state, and when the glass is being made, but it does not solidify. Okay, it does not solidify until and unless it reaches a temperature that drops below its melting point. So the material needs to be cooled further, and this, cooling down basically gives the amorphous structure of glass. So that basically defines the structure of glass. Now, when we make glass, we know that we add several other things as well. Okay, so there are different materials that are added. So here the question is the role of potash in making glass is. So there are several other materials like the coloring agents are added, borax is added, lead is added, but each and everything have their own different function. So here the second question asks about the role of potash in making glass is. Any answer from you all? Okay, I'll open the chat box. Yes, the last question, the answers by Harsha, Rohit, Harini, all were correct. Okay, I got answer from Harsha saying that it acts as an accelerator for fusion of glass. Any more answer for this particular question? Okay, so let me give the answer. So it basically makes the glass resistant to fire. Okay. So if you once again just go back to the course module, you'll find that several other, components, for example, soda or potash or oxides of iron, then lead or borax. So all these things are even coloring agents. So all these things are added because they have got very specific kind of role. Okay, when you are making this, when you are manufacturing glass, so soda basically it acts as an accelerator for fusion of glass. So it will enhance the speed. Then when we give put some potash into it, so it makes the glass more resistant to fire. Okay. Then there are oxides of iron, which gives hardness. Okay, there is lead, which gives the shine or the brilliance. Okay, then there's this borax that gives the color. And of course, there are several other coloring agents also we have seen, and each and every type of coloring agents, they have got their own individual role. Some imparts the color like yellow, deep yellow, amber like color. Some gives the greenish tone. Okay, so this or the different types of agents are also used to impart color. For example, if you are making stained glass, so that these colors will be useful for that purpose also. Okay. Okay, so I hope the second question was clear to you all. And now coming to our third question, which says that which of the following mentions the correct range of values of G? So G is basically the solar heat gain coefficient of glass. So I'll talk about what is solar heat gain, but before that, any answer from you all? Okay, Tubaya says 0 to 1. Okay, any more answer? Yes, it's absolutely correct. So the value of solar heat gain ranges between 0 to 1. Now it's easier to say, okay, solar heat gain of glass should be between this range, and for this kind of temperature, the solar heat gain should be this much. But what exactly is solar heat gain, right? That we need to understand. So if we look at solar heat gain coefficient, okay, it's SHGC. So when we understand that just this, if you look into this particular image, you can see that this is a particular, this is a fenestration or an opening. Okay, so this particular thing is an opening, and this is the outside. So you can see the sun over here, and this is the inside space. Now what happens? The due to the solar radiation. Okay, so there this is the incident solar radiation you can see. Now some part of the solar radiation is transmitted, is directly transmitted inside. Some part of it we know that it is, reflected. Okay, so we know that reflection happens, then absorption happens, absorption of heat or the radiation, and then transmission happens. So these are all, different stages how the incident solar radiation is either, it's reflected or it's transmitted or it's absorbed by on the body on which it is falling. So it depends upon the physical characteristics of that particular material, of that particular element on which the solar radiation is incident on. Okay, so depending upon that, this reflectance value, the absorption value or the absorbance value or the transmission value, these are all different. But we need to understand that if we represent it with R, A and T, so basically we know that R plus A plus T is equal to 1. So 1 is the total amount of incident solar radiation, and all these components together will give you a value of 1. Okay. So basically now I think you all are getting into the thing that when this incident solar radiation is falling on the fenestration, which is made up of glass, so some part of it is directly transmitted inside, some part is absorbed, as you can see it's written over here, some part gets reflected. So reflected part and the absorbed part, we are not really bothered about it, but we are bothered about the transmitted heat, and also a part of it gets re-emitted. Okay, so you can see how this re-emittance happens. So this re-emitted heat and the transmitted heat, or for very simpler, if you don't want to go into this re-emitted heat, what is it and what not, you can also just consider this the directly transmitted heat as well. So it's basically the ratio of the transmitted heat. Since we in this particular scenario, we can also consider a re-emitted heat, which is this expressed in terms of F divided by A. So A is the total uh, incident solar radiation. So what fraction of solar radiation that is admitted through this particular fenestration, okay, to the the total amount. So that is what is all about solar heat gain. So how much of it is, so how much of the solar heat is basically gained. So that is that you can, like, in simpler words you can say it in this way. So if you see that the solar heat gain coefficient is less, okay, so what does it mean? So it basically means that less solar heat is transmitted, okay, and greater will be the cooling capacity or the shading ability of that particular fenestration. So what do I mean by fenestration? Fenestration is basically the opening, okay. It can be a window, it can be a skylight, it can be in forms of a door maybe, okay. So its fenestration is basically the opening. Now, also in cold climate, just imagine about just imagine you staying in Kashmir and or any other hilly areas. Okay, so what will you expect? Will you expect your room to be very cold? Obviously, no. You'll want your room to be warmer. So in such a scenario, what will you want? You'll want that there is more of heat gain. There is more of solar heat gain. Okay, apart from the mechanical things that we can use, for example solar, for example heater and all those things. But just imagine if you can utilize the solar energy and if you can increase the heat gain inside your room, then that will be beneficial for everybody. So in cold climate we want the solar heat gain to be high so that the heat is greater, okay. Also we use this insulating glazing units. So in our course also we have seen how ma'am talks about insulated glazing units. So in insulated glazing units, what we have seen, so in insulated glazing units we have seen that there are two or more than two panes of glasses. Just imagine this to be like these are glass panes. So two or more glass panes are there and they have a particular space between them, okay. So what happens, and also this particular place, this the glass panes are placed in such a manner that they are sealed with a sealant, and it looks as if that it's just a single glazing, but actually it's not, because there are two or more glass panes. So this particular units, insulated glazing units, are designed so as to reduce the heat loss. Okay, so you can well understand that in cold climate, you are not only allowing more heat gain. Okay, apart from that, you are also thinking of ways so that the heat that has already been gained should not get lost. Okay, so that is why in cold climate we use insulated glazing units with high SHGC or solar heat gain coefficient that allows greater heat. So this is the entire fundament or the entire process or mechanism, whatever you want to say, about solar heat gain, and where we should use solar heat gain. Where we should have mechanism that has the capacity of gaining more heat, and where we should have less heat. So this brings to our next question. I hope this part is clear to everybody. And if and so this brings to our next question. If you all have any queries, just put it up. So you are designing a building with glass facades in a cold climate area. Okay. Now, while selecting the type of glass, which of the following will you choose? So you have glass with solar heat gain coefficient of 0.15, 0.35, zero point 0.6 and 0.86. So what will be your selection? Okay, see Harsha says D. Yes, Azizu. I hope I'm spelling it correctly or pronouncing it correctly. If you have any doubt, you can unmute yourself. Azizu, you can either unmute yourself or you can also write on the chat box if you have any kind of question. Okay, I
Yeah,
see.
yes,
Yes,
yes.
Azizu.
Good evening. Have a nice to meet you.
Yeah, you have any question or and
0.86.
I can't hear you properly. I'm sorry. Uh, can you just type it out?
Sure.
Okay, I think there are some issues. So I would request Azizu to just type it out. Okay. Okay. So let's see what's the answer. I got just one or two answer. Harsha says okay. See, as I was just discussing that. when we are selecting a glass with solar heat gain and you have the option of 0.15, 0.35, 0.60, 0.86, so obviously you will select particular particular type of glass that has got more of this solar heat gain coefficient, right? You wouldn't want a particular glass that is having lesser solar heat gain. Like as Aju says that it's B, but you have other options with you. For example, 0.60, 0.86. Yes, since 0.86 is the highest, that is why 0.86 is the answer. But yes, don't think that 0.86 is the is the answer, like not answer, but it's always like solar heat gain coefficient of it will be 0.86 only when we are selecting glasses for cool climate. It's not that. It's for this particular question, since it is the highest value, we will accept this as the correct answer. Okay, I hope this is clear with everybody. Okay, now let's move into a bit of a different question. I'll once again come back to solar heat gain part, not solar heat gain directly, but yes, I'll have another question because I feel that insulation is a very important topic in itself. But before that, let's look into some other questions as well. So here, what does the question say? It says that read the statements P and Q. Just a second. Yes. So first statement says tempered glass can be cut, and another statement says tempered glass cannot be welded. So you have to choose the Azizur. Yeah, Azizur. Yes, yes, absolutely correct. I understand. You're answering about the last question. Yes, very good. Okay. So Rohit has answered statement P is wrong, but statement Q is correct. Any more answers from anybody else? Okay, Tobias is D. No, no. It's okay. Okay, Rohit suddenly says that answer will be D. No, no, no. Rohit, you gave the correct answer at first. So it's okay. So all of you are saying that. I mean, yeah. Till now, the answers that I have got, it says that both the statements are wrong. See, tempered glass can be cut. This is a wrong question. Sorry, this is a wrong statement. Okay, tempered glass cannot be cut. At the same time, tempered glass cannot be welded. Okay, so this is a correct statement. So only before it should be done beforehand only. Before it is, the temperature, it is put into the temperature and it is prepared. But if you go back to the slides that map has taught, you will see that all this cutting, all this welding has to be done beforehand only. So that is the reason tempered glass cannot, it cannot be cut, and neither it can be welded. So let us just see. Before I go into that, I have another question, and then I'll go into one particular discussion. So here it says that what kind of glass is used in curtain walls? Any answer from you all? Okay. Most of you all are saying plate glass. Okay. Well, the answer is actually tempered glass. So all of you are saying plate glass. No, no, no. See, plate glass is something which has, why tempered glass? I'll tell you that. Maybe that will, make other things clear as well to you all. See, tempered glass is basically, it's the toughened glass. Okay. So this type of glass is used where, where you need to, have more strength. So if you look into plate glass, as you all were saying, so what is a before that, maybe I'll just explain you with the curtain walls thing. So curtain wall is basically something which forms the non-structural part. Okay, it's generally placed in the outside of a building, and it forms the non-structural part. So when I say non-structural part, what do I mean by this non-structural part? It means that it does not transmit load of the building. Do not. Okay, that is what non-structural is all about. So what happens? This curtain walls, they are, if you look into this particular image of this particular section, so you see that this curtain walls, they are basically, a particular framing is done, and since, as I said, that it's a non-structural thing, so it's just fixed with the main structural element of that particular building. So the glass that is used need to be in, it needs to be made of such a thing that it does not easily breaks. And also this particular curtain walls and all these things, these are mostly used in high rise buildings as well. So just imagine you have a high rise building, you have designed it beautifully with this curtain walls, and then suddenly this plate glasses which are not having much of strength, mechanical strength, it just breaks, and you have to again replace it, and it's an entire headache, right? Because plate glass does not have the required this particular mechanical strength or the toughness that it should have, or that the toughened glass or the tempered glass have. Okay, so obviously what will happen, you have to replace the particular glass you have placed it, and that is quite a hassle. So for that reasons, this curtain walls, when we are designing curtain walls, we use this tempered glass. And this tempered glass are basically not only in case of curtain walls, it has got several other applications as well. So suppose if you look into this particular staircase, so in this particular staircase, you can see that, so it's a staircase basically. So people will climb upon it and move up and down. So it has to have the capacity to hold the weight of a huge traffic. So this toughened glass as such, it is made up of the entire process of making this tempered glass or this toughened glass is made in such a way that it can withstand the load that is that you put on it. So its strength basically is quite high as compared to the normal glass. And also if you look into this, how this tempering happens, this when this tempered glass is basically tempered, then what happens, the outer surface, it goes into compression and interior into tension. Okay, so what happens, such stresses can cause the glass. Okay, and but this tempered glass, since it's made in such a way, it's made in such a high temperature, for that reason what happens, this annealing process happens. Okay, and more, and it has got its strength, mechanical strength, which is more than any ordinary glass. And that is why when this particular tempered glass breaks, it generally forms into this granular chunks rather than into those very sharp edges and all those things that generally we think of when we find that glass has broken. So these are some of the vital this characteristics of this particular glass. And also we see that this due to this annealing process. So what is this annealing process? It's basically heat treatment. So you are giving a particular heat at a particular temperature, so that is basically changing the entire characteristic of that particular glass. So that is the process of annealing. So by giving that, you are turning a very ordinary glass into a very toughened glass. So that is why this particular type of glass has got application, as I said, in numerous other places also, where your priority is safety, but at the same time maybe you want transparency. Okay, so here this particular staircase that you see, maybe you can also argue or you can put up on debate that it's just for aesthetic purpose. Yes, it is, but there are other very practical. I won't say this is impractical, but yes, there are other very practical and very there are different ways where you can use this tempered glass. Okay, I hope this part is clear to you all. Now, once again, I'm coming back. As I said, that I'll come back to this particular question. So, yes. So, the details of two types of glasses are given below. Select the best one for an area with very hot day and cold night. So, it's basically the desert climate. So, in desert, what happens? So during the daytime, it's very hot. Okay, but in night time, what happens? Temperature drops, and it can drop to as low as this particular near to 0 degree Celsius. So it's very common that at night, in the morning, in the daytime, we found that it's 42 degrees Celsius, and then in the night time, you find it's 2 to 3 degrees Celsius. So this is a very common thing. And so in this type of uh, climatic zones, what are you going to do? So previously we have seen about um, cold climate region, where we have talked about that SHGC should be in the higher side. Now you have two criteria. One is the U value, okay, and the other is the SHGC. So SHGC, you are clear about it. U value, try to answer this one. Okay, ma'am has also taught in our module. But yes, if you can't, I'll definitely explain it to you once again. Yes, any answer from anybody? Okay, I see Rohit has answered. Rohit Harsha, both of you says A. Okay, it's a bit tricky question. That's true, but I'll see. Okay. So basically, my answer is SHGC of 0.25 and U value of 1.9. So maybe I'm wrong, but I would request you all to correct me if this is wrong. Okay. See, what did we say? We have already talked about SHGC, so I'll not talk about it once again. But now let's just see what's U value is. So when I say U value, so it's basically means that how much of the glass is able to or basically what is the insulating capacity of the glass. So basically what is the insulation, or how the insulation is happening. So that is what, how are you going to measure? I was saying that okay, this particular insulated glass units, IGUs, okay, but how are you going to, there should be some kind of measure also, right? That okay, so this particular value will help us to understand that the insulating capacity is this much for glass X, this much for glass Y. So you need to understand that. So in order to understand that, we have this particular thing called U value. Now, what is this U value? Okay, so this U value basically represents that how quickly heat from hot air will pass through the glass and not the direct sunlight. So it's the heat. Okay, and now it's not the incident radiation. So there is a difference between this incident radiation or the direct sunlight and the heat that is generated. So for SHGC, we have talked about the radiation, how much of it is getting transmitted, right? But for U value, we talk about, we have to focus on the term heat. Okay, so if you have lower U value, that means better the insulation. Okay, and also glass with low U values are kept to keep the warmth in room, particularly in cold climates or at night. Okay, so here comes the thing. So here we have taken up a particular example where we had this diurnal variations. Okay, so diurnal variations mean, or high diurnal variations. So what do I mean by diurnal variations? Which means that in the morning the temperature is very uncomfortable in terms of its hotness. Okay, you won't want a particular place to stay where the heat is captured at a higher rate. So for that reason, what will you select? You will select that your type of, if you are providing fenestration and you are providing glass, so you will think about it. Okay, the solar heat gain capacity, or sorry, the solar heat gain coefficient should be low. Okay, and at the same time the U value will also be such that at the, it will be utilized later. So you have to understand there's also concept of time lagging also. We do when we are I mean, this is not a part of this module, but we have to do calculations also when it comes to, it's a part of climatology where we actually calculate the time lag. Okay, so it's not that the sun rays are incident on it and instantly the room gets heated up. It doesn't happens like that, right? so it takes time to get heated up. So that is basically, what we, again the heat gets dissipated. So what happens, the entire room gets, suppose if this is the outside, sorry, pardon me for the kind of drawing, but yes, if you just imagine it to be the wall with a particular fenestration, so the incident light is falling. But you have to also understand that heat, I talked about heat and I talked about incident radiation. So these two things are very different. And it's a lot of calculation. It's not as simple as I just showed you by giving, just two numbers. But we actually need to calculate that, how much of time it is getting so that the inside gets heated up, and accordingly we actually select the u value, the type of, glass that should be selected. But here, for our easy understanding, or at least for the fulfillment of the course that is being provided to us, this much of it is, I hope it's, it will be fine for all of us. So glass with a very, with a low SHGC, as I have said, is used to reduce the amount of heat coming through the windows in summer. So this is the basic, fundamentals about this SHGC and U value. So if you look into this particular image also, this particular image is, I hope it is showing it now. So this particular image will make your, it will make your the concept clearer. So it's the sun, and you can see the G value, that just what we say, the SHGC. Okay, so it's how much of the ray of the incident ray is getting transmitted. But when we talk about U value, it is about the how much it is getting heated up, and also how much of heat loss can happen. So that basically is represented. How much of thermal heat loss can happen, or how much of insulating capacity that particular glass will provide due to the use of that particular glass that you are giving. So that is basically represented with the help of U value. And also we have also seen that U value can be, controlled by using different kinds of, glass things. Yes, right. So here, if you see here, we just if you use just a ordinary single glazing, so the U value will be very high, right? Whereas if you use, standard double glazing, just two double glazing, and there's this air gap between the two glazing, so then you can reduce the U value to some extent, 2.81. It's showing over here. So I mean, you don't have to memorize all these values. Okay, I'm just showing you how things can change. Even this has been discussed in your module also, in the videos also. So there also you can go and check. Ma'am has shown different other, graphs or images, rather. To explain this particular part, and this is a bit different thing, but the main concept is same. So here, suppose you're using argon gas, okay, in between that, two panes, glass panes, so that further reduces your U value. Once again, if you have something like low E, okay, so what's this low E helps you? If you have this low E, then it will prevent this particular coating is, used when you want to minimize the, ultraviolet, lights to enter your particular, inside the room that you are staying, or whatever you're designing. So this particular low E will further reduce. And then if you have double glazing, low E, argon, all these three things, then you get further lower value. So this is how you can see how the U value, or how the, thermal heat loss, or how the insulating capacity can be controlled with the help of, different elements, or different, things that you are uh, using. So this is the very, this is the beauty of how, I mean, how the glass buildings are designed. So all these things are kept in mind when we see those tall glass buildings. I'll also show you all some of the very beautiful, maybe no, I mean, I don't know whether you all will find it beautiful or not, but it's those are, some pieces, masterpieces. Okay, so let's come back to our eighth question, which says that choose the appropriate coating for, I hope, yeah, it's visible, for making hydrophilic and hydrophobic glass. So let me just tell you, hydrophilic and hydrophobic glass, these are what? Self cleaning glass, right? Now give me the answer if you can recall. Thank you, Rohit. Okay, Harsha. No, Harsha. This answer is, I think, not for this one. This will have two answers. Okay, not one. No one? Okay, I'll give the answer then. So basically, hydrophobic is, in order to get a hydrophobic glass, you can use silica gel, or even the microscopic contours can be added, so that also gives you a hydrophobic glass. But yes, this is one of the way. And the other is hydrophilic. So hydrophilic we can get it by adding a coat of titanium dioxide. Okay, so hydrophilic and hydrophobic, I'll explain it very briefly. So if you look into these two images, it will be much more clearer. Okay, so this is a hydrophilic. So hydrophilic, the term itself means that, a molecule is basically attracted to water, or basically it's a love. Or when I say hydrophilic glass, it means the glass loves water. So that is what hydrophilic is. And phobic means we already know the idea of phobia and all these things. So hydrophobic means the glass is basically it is water hating. It does not like water. So the characteristic of hydrophilic and hydrophobic will be very different. Now, if you ask me the purpose, yes, both are having the purpose of self cleansing. Okay, that's true, but also where do we apply? So also it depends upon the kind of cleaning mechanism that is available. So that is also important whether we select this hydrophilic or hydrophobic glass. Okay, so that's the basic thing about choosing hydrophilic and hydrophobic, because both are ultimately self cleaning glasses, right? So of course, some of you might say that there are advantages of hydrophobic over hydrophilic, because we have also studied that hydrophilic, it cannot carry down all the dirt and dust sometimes, whereas hydrophobic, due to the way it actually falls or runs through the glasses, maybe because of that it's able to carry down the hydrophilic. If you just imagine the water, so what happens in hydrophilic, I just explained. So hydrophilic, it runs like sheets of water. So it's this, if you can look, so what happens, it spreads, the water just spreads like sheets. Okay, and then it takes away dirt and all those things. Another thing, what happens, as I said, hydrophilic is water loving. So suppose you use soap water, then also what happens, this hydrophilic water will attract this soap particles and all those chemicals. And as a matter of fact, instead of getting a proper cleaning, it will be a kind of mess. Okay, if we are using this soap and all these things for when we have this hydrophilic glass. Whereas hydrophobic glass, this has got a very different kind of a mechanism altogether. Now, hydrophobic glass can be again of two types: super hydrophobic glass and ordinary hydrophobic glass. So here you see it's a half or a hemispherical kind of a droplet is formed. But if it's super hydrophobic, then the spherical kind of water droplets are formed. So what happens is that instead of spreading across this entire glass, what happens for like hydrophilic glass, what happens for hydrophobic glass, it basically it forms this bead kind of thing. Okay, or it forms like droplet kind of thing, and it rolls down. So it rolls down, and when it rolls down, it takes it with itself the dirt and all those things, and it cleans the glass. So these are, so instead of making sheets, basically falling in sheets of water, it forms rivers like this. you know this is the basic difference when we wash hydrophobic and hydrophilic glasses. Okay, so you have seen what kind of materials can be added. And okay, let me just a second, it's taking time to. Okay, here comes our ninth question. Can you, yeah, can you identify the wall construction technique over here? The answer is from the, the things that you have learned. Anybody with any answer? Does it looks anything similar that you have already done? Okay, so this is basically glass fiber reinforced gypsum panel. No, no. Yeah, good that you tried. Yes, this particular image might be misleading as well. Like you might think of different, since we are talking about this particular course or particular lecture module. Maybe we can think, but yes, if you look into this glass fiber reinforced gypsum panel, this looks like this. AACs are a bit different. Okay. Uh, okay. So, so what are this GFRC or sorry GFRG? It can be concrete as well, or this glass fiber reinforced gypsum. Just a second, it is taking a bit of time. I don't know why, but yes, I hope now it's visible. So, what is this GFRG? So, these particular panels are, as you can understand from the name itself. So, gypsum is there, reinforced. Okay, so only thing is that one here you are using gypsum, and in it you are reinforcing it with glass fiber reinforcements, whereas GFRC is basically the concrete. Okay, and there you are using glass fiber, reinforcement, glass fibers as reinforcement. And what happens? How do we prepare this? So as I said, so it's as you understand from the name itself that within gypsum or within this concrete, you are using glass fibers as reinforcements. Why? That is basically increasing the strength, you can say, and also it's a lightweight material. At the same time, it is having higher strength. So that is why we use this, GFRC or GFRG, whichever is, whichever is possible. So what happens? Just a second. This particular material was is also known as rapid wall, and it was first introduced in Australia. And this particular material has the capacity of bearing the entire load of the building. So that is what makes it so unique, that it is lightweight, and at the same time it is making the entire thing. I mean, it can withstand the load of the entire house. If you also go into this, ma'am was also talking about BMTPC. Okay, so if you look into their particular website, also you see that how they have used it for rapid construction of mass housing. So mass housing are, you have to basically, the concept of mass housing is all about giving providing housing to a huge number of people. And when you're building this mass housing, in such a scenario you have to think of something which will, in which you will be able to make buildings at a very faster rate, and at the same time it will be like durable enough so that people come and stay. Otherwise people will won't they won't have that, they wouldn't like to come. So, keeping all these things in mind, GFRG or GFRC, these two are, these are basically used for building the exterior building facade panels, and these particular things are used as precast concrete. So, you can say that they are casted previously, and then they are put on the place. So that is what this particular GFRG panels do. And since it's lightweight, it can be used for load bearing walls, it can be used as floor slabs or roof slabs. Okay, it can be used as staircase waist and landing slabs as well. It can be used as sunshades or chachas, whatever you want to say. Okay, so all these things are used. Okay, so that brings to our, I hope this GFRG thing is clear. Okay, so what's the next question? Next question is glass block machinery. So we have already seen what are glass blocks, and here the question is about glass block masonry. Yes, anyone? So glass blocks are basically glass bricks also. You can see they are also known as glass bricks, right? So they are, two glasses are basically, you know, they are attached to form brick-like structure with the help of glass. Okay, no one with, oh, sorry. The answer is already displayed. Right. Yes. So basically, if you look into the first option, it says that improvement in resistivity can be obtained by adding steel reinforcement. No, this is not possible for glass block masonry. But yes, stiffer and drier mortar is required for glass block masonry, because otherwise, you know what will happen. I'll discuss again once again. And also, edges of this glass blocks are painted with polyvinyl butyrol to improve the mechanical bond. Okay, and the other option is also it's not correct. So if you look into glass block, these are, as I said, that these are basically the glass bricks. And when we talk about glass block mortar, so these are some kind of, either, this mortar is made of this Portland cement. This is again a type of cement, sand and some chemicals. Or we can also use this S Portland cement and lime mortar. So it depends upon what kind of mortar you are using. But you have to understand that this particular mortar should be stiffer and drier, because otherwise what will happen if you think about the normal mortar and the kind of workability that can be done with the help of bricks, okay, the clay bricks, it's very different. Okay, bricks, if it absorbs water, then it's okay. But no water absorption by glass. So glass, it's made in such a way that water cannot be absorbed, and that's one of the reason that mortar should be, stiffer and drier. And apart from that, as the particular question already said, that we can use this polyvinyl butyrol or latex paint so that we can improve the edges, okay, improve the mechanical bonding at the edges. So these, just imagine, and you can put it over here. These are the blocks. Okay. Also, steel reinforcement may be embedded. Okay. However, partial vacuum gives high thermal resistivity equivalent to this double glazed units. These are double glazed units. And argon infill can further improve the resistivity. Okay. Okay. Now coming to our last question. So this is basically the last question that I have for you all, which says that you have to fixing of tiles. It's a question about fixing of tiles where you have to find the correct answer. This one, or yes, any answer from you all? No one? Okay. I'll should I give the answer? Okay, I got one answer. Two answer. A and C. Okay, this one and which one? C. Okay. Hmm. Okay, so C is correct. For wall tiles, fixing may also be done with the help of chemical adhesives. That's correct. I get another answer saying A is correct. This answer is actually a bit, it's a tricky one. If you look into the this lecture material or the videos also, you'll find that the ratio is different. Okay, it's not cement and mortar to be 1:4. Rather, it's the opposite. It's 4:1. And also, cement slurry is not required for fixing wall tiles. Instead, for floor tiles, we can use this cement slurry directly. Okay. So this, that is why this particular option is not correct. Then, okay. Serrations are required to be made in the slurry layer for fixing tiles, but they are not important for fixing floor tiles. Once again, no, it's wrong, because we have seen in the images that serrations are important. Serrations are something like this. Okay, So it's so that the bonding between the mortar and the tile is, it's strong. For that reason, serrations are required and the tiles are placed properly. So, of course, serrations are required. Next, for wall tiles, fixing can be done with the help of chemical adhesives. That's correct. Okay, so this part is correct. And also, spacers are used. So, spacers are basically, between one tile, you give a particular gap and you fill it later on with other kind of, the material. And these are basically given so that, you can allow for a bit of this expansion during the temperature changes. So option B is also correct. Okay, so C is correct, D is correct. Am I clear with the this particular question and answer? Okay. So I'll just quickly explain. So we have learned about ceramic tiles, we have learned about vitrified tiles, right? So what is the basic difference between the ceramic tiles and vitrified tiles? So ceramic tiles are purely made of, clay mixed with water. However, for vitrified tiles, we also include silica, quartz, feldspar, all these things are added, which makes this vitrified tiles, and the other one is the ceramic tile with just clay. Okay, however, we have seen that ceramic tiles are less durable than the vitrified tiles. If you look into the process, how this particular, this tiles are made, so if you look into the exact process, you will see that first the raw materials are, taken, and then after that they are batched. So in batched, so what do I mean by batching? So in batching, what happens? The raw materials are basically, accumulated or put in appropriate proportions. So milling and spray drying, all these things are done when this particular raw materials are, put in proper proportions, or these processes are done. And then what happens? Then the process of hydraulic pressing, or you can say pressing also, so as you wish to say. So this thing basically happens. So this hydraulic pressing or the pressing process, it helps in the compaction of all the materials that you are using to make tiles. Okay, so this is the utility of this particular hydraulic pressing. Then what happens? Then you need to dry it. Then after drying it, you need to glaze it. So we have also studied that glazing is a particular process where we add some kind of, enamel coating over the tiles, or we add molten glass over the tiles. So that is what this glazing, process, or the glazing step is all about. And for that reason, you need some kind of glaze preparation. So that is again a different kind of a process, or that's a different step. But yes, glaze preparation is obviously required because it's a different other material that you are putting on top of it, okay, or on it. So glazing is done. After that, firing is done, and finally, or firing, or it is also known as vitrification. Okay, so vitrification, basically you are firing the unfired tiles. Okay, and then the final material is available to us. So this is the entire process of how tiles are manufactured. Okay, I hope this thing is clear to you all. So all the steps, they have got their own, requirements, like why we do batching, so that, we can appropriately provide the kind of, required raw material. The proportion should be correct. Okay, so that we get good quality tiles. Also, we should see that why do we do vitrification? Okay, so that we can impart strength. So all these things are there. So each and every step has got its utility, and each of the step is very distinct as well. Okay, this part is clear to you all, tiles and all. Okay, I'll just show quickly some of the, some buildings made of glass. So this is one particular very famous building. Uh, this is known as the Glass House. It's in United States, and it was designed by architect Philip Johnson, and he used to stay over here. And yes, absolutely correct. Okay. So he stayed here also till he died. and this is one fine example where this glass is used. Then this particular building, this is can anybody answer this one? This is also a very well-known building in London. It's the 30 Saint Mary X or the Gharkin. Okay, so this particular building, if you see the profile, the elevation of the particular building, you'll say that, so we have used, not we, I mean the architect have used, circular or curved glass plates, right? It's very obvious by looking at the shape of this particular structure. But very interestingly, not a single piece is made of curved glass except the very top one. This particular one top, it's just that is just one particular glass, that is curved. But other than that, all the other glasses that have been used are actually, it's the street or the non-curved glasses, and that was possible only because of this diagrid framework. So this diagrid framework is a very, it's a structural framework, and it's mostly the framework is made up of steel in the high rise buildings that we see, and where the framework basically, it diagonally intersects, so it looks something like this. And you know this the glass is basically this one. So in this manner, if you keep on putting, you can give it any shape, any kind of shape you want to. So that is how this particular building is. So this one example you have also seen. Oh, just let the screen change. Just a second. It's taking a bit time. Now it was showing, and then again I changed it, and again came back. Oh, yeah. Now it's showing. So this is the Louvre pyramid in Paris. So this is again, okay, the next particular slide. Today there's a bit of difficulty in my, maybe in the network issue, institute network issue, because somehow it's not syncing. Yeah, Rohit says it's Louvre pyramid I am paying, and the I hope the last building is visible to you all, because it's not showing in my screen. Just a second. Yeah, now it's showing, I hope. So it's the Al Dar headquarters in Abu Dhabi, UAE. So again, if you look at this particular building, you will find that, okay. So this is basically looks like, I know it's something like this. So you might wonder that, okay, so curved shaped glasses are used, but very interestingly, curved glass skin, although it looks like, curved glasses are used, but actually it's not, because again this diagrid structure has been used, where this, triangulated pieces of flat glass are combined into this diamond like shapes, which has given the entire form, or the entire elevation looks, or the elevation can be made with the help of glass, because of this particular, form work, or this particular structure. Okay, so that is what there are. You'll find there are several examples of, usage of glass, and the structures are huge, and they have got different forms. Particularly, if you look into the works of Norman Foster, Richard Rogers, Renzo Piano, so all of them are high tech. It's known, they are known as high tech architects, or the examples of high tech architecture. All these things. So you'll find, and you can, like, always go through it and see how, apart from the simple fenestrations or the simple windows and glass panes that we see in our day-to-day life, apart from that, a huge kind of contribution is there by different architects, and how the glass is explored widely uh, in this particular field of building and construction. Okay, so that brings an end to our today's lecture. So if you all have any question, we can, or if not, then we can call it a day, and hope to see you all in our next problem solving class. I hope this class was helpful for solving the assignment as well. Okay, thank you everyone. Thank you Rohit, thank you Bhavna, Aliu, thank you.